Hello everyone. This investigation is called the naked egg experiment, and we are looking at eggs whose shells have been removed and the eggs have been placed overnight in different solutions. This egg was placed in water alone with no sugar in it. This egg was placed in a very highly concentrated sugar solution. This egg was placed in a medium sugar solution, and this one was placed in a salt solution. So by putting eggs in different solutions overnight, you can get different amounts of water going into the egg or coming out of the egg. And it's a great introduction to cells, to membranes, and to osmosis. This is an experiment that I like to do as an introduction to cells. It's a great way to get kids to see what cells are like. And I also introduced the concept of osmosis and membranes. I do it with 15, 16-year-olds, but I think it can be adapted to almost any age, depending on how much depth you want to go into. I like it because it is using very simple ingredients, and kids like to get their hands, dirty and get the hands-on experience. And once you remove the shell, it often impresses students that inside the shell you have this wonderful model of a cell, and it helps them to see that cells are three-dimensional things. Very often in biology books and posters, cells are shown as flat, pizza-like structures, and in fact they are, of course, 3D objects. Okay, so here's what you need for the experiment. Lots of eggs. I use chicken eggs, but you could use other types of eggs. You could use beakers to remove the beakers of vinegar to remove the shells, but in a low-tech lab you can just use plastic cups. It's a good idea to soak the eggs for about 2 days. I suggest switching the vinegar after a day to make sure it's fresh solutions and that all the shell comes off. This part can be messy, so if you're with a group that you don't want to make too much of a mess with, you can do this in advance. So here's one that's been prepared where all of the shell has been removed. Sometimes there are residues of shell that are still left on there, so if there's anything white on the outside, that should be either gently scraped off without breaking the membrane, or just put in vinegar for a few more hours. A fresh solution of vinegar. The next thing you want to do is get the students to try to measure the either the volume or the mass of the egg, or both. So by using a scale, you can get students to measure the mass. If you don't have a scale, you might want to think of more ingenious ways of measuring the mass. Measuring the size of the egg, the volume, there are lots of different possibilities. One is to get a paper ruler that can go around, or maybe a piece of string, and then measure the string on the ruler to get the circumference. That would be the simplest. If you have a way of dropping the egg into water and displacing the water, but then collecting the water. In our lab, we are lucky to have these nice little beakers with an overflow spout, and these allow us to fill up the beaker with water, put the egg in gently, and any water that comes off is going to be the volume of the egg. And again, if you have the equipment, you can measure that volume in a graduated cylinder. That needs to be done at the beginning of the experiment to get a before value. And then we place the eggs into I like to call these naked eggs, the ones that have no shell. Place the naked eggs into solutions that could either be salt solutions or sugar solutions. I use sugar solutions usually, but we want to see what happens to the volume and the mass of the egg after they've been placed in these solutions. So we set up either a distilled water solution or tap water works just fine, so something that has nothing or almost nothing dissolved in it. And then maybe some intermediate solutions if you have the resources. And then something that's very, very thick and highly concentrated. I use glucose syrup, so it's very, very highly concentrated sugar solution. And I leave the eggs overnight
and then the students, next time I see them, can take the eggs out and again measure the mass and measure the volume with whatever technique they used and see the difference. But I think even just looking at them, they'll be surprised to see the contrast between the highly concentrated solutions and the water with nothing in it.
Okay, so here we are on day 2, and we have our distilled water, or just regular water. We have an intermediate sugar solution, and then we have our glucose syrup, which was the highest concentration of sugar. At this stage, I get the students to do some qualitative observations, looking at colors, how has the egg changed overnight, looking at the texture maybe. Eventually they'll be taking the egg out and they can actually see and feel differences. But certainly just starting with the visual is a great way to remind kids of the importance of qualitative observations. At this stage, students can start to think about whether or not their hypotheses were confirmed or refuted. And I get students to use those words rather than using words like right or wrong for a hypothesis. I think it's better to say a hypothesis is confirmed or is refuted by the data. So let's take these out. So this can get a little bit messy. Let's maybe start with the distilled water, or the no sugar solution. Be the least messy. So already students can see that this is quite full of water. It should feel heavier and feel the membrane here should feel tighter. And really it should be weighed, and the mass and the volume should be determined as quickly as possible. Because that's another qualitative observation that students can make, is that even if they dry it off with a paper towel, they'll feel that it's kind of sweats in their hand. They'll feel that it releases a little bit of humidity, and again, that's water escaping through the membrane. All right, that's the zero sugar solution. Let's try the intermediate sugar solution here. So this one's, maybe compare the two. Just visually, it does look like this one is bigger than this one, but that would have to be confirmed with the measurements. And that's where it's important to say to students how, even if something looks bigger, you should really measure it and get some numbers. That's the difference between playing and doing some science, is you actually get some numbers involved. And here with the most concentrated glucose syrup, there's an interesting phenomenon that happens that some of the more observant students will notice, and that is that the distilled water, the water that has come out of the egg, because as we can see, it's shriveled up a little bit overnight, quite a bit actually. That water has been released near the egg, and the glucose solution, which is more dense, accumulates at the bottom, and in fact it forms two layers, and the egg is kind of sitting on the top layer, so it's kind of flattened out. Okay, so we'll remove this one. And there we can see that it's really quite different from the one that was in plain water. So this was the no sugar solution, and this was the very, very intense, very concentrated sugar solution. And so here there's some great qualitative observations in terms of how soft and wrinkly the surface is. There's very little resistance. The yolk sometimes becomes quite hard inside. That doesn't seem to have happened this time. But again, students can make observations with color and texture and all kinds of things before moving on to the quantitative results. So for the quantitative results, we want to do the same thing we did on the first day, that is to say, get the circumference of each egg, get the mass of each egg, and if possible, the volume. Invariably, at the end of the experiment, students often ask if they can break the eggs. That's up to you. Some of them break them accidentally, and it's good to remind them to be super careful during the experiment that they don't break them, because then they won't have any data. But if you have some kind of recipient that can collect the mess, I often get kids to see how high they can drop the egg from without it breaking, and then eventually it does break.